Let's continue looking at the inverse function on the relation functions and graphs. Now, we're going to see that a function and its inverse can be used for encryption and decryption, can be used for encoding and decoding. All right? What I have here is a function f of x equals 3x minus 4. And these numbers represent the PIN number to access your ATM card. Or let us say that, imagine that this is your PIN number. And let's say you're not able to go to the ATM. So you give a family member your ATM card to draw some money for you. And you're going to send them a message. And that message will be what the PIN number they should use. Now, it's that you're on your phone. The message is going to be encoded before it is sent out. And then on your family member's phone, it's going to be decoded. Now, between sending out from your phone and your family member's phone, you suspect that the scammers are using some type of device to intercept your messages. And what they will see is not your PIN number. They want your PIN number to empty your account. But what they will see is the encoded message. So, let's pass these numbers through the function and see what would happen. You have f of 1. Let's put 1 in there. F of 1 is 3 times 1 minus 4. 3 ones 3 minus 4 is negative 1. So what comes out is negative 1. Then put 3 in it. F of 3 is 3 times 3. 3 times 3 minus 4. 3 is 9 minus 4 is 5. So what comes out is 5. Then 7. You have f of 7 is equal to 3 times 7 minus 4 is 21 minus 4. What is 21 minus 4? 17. So you have 17 here. Right? So this is 17. And when you pass 6 through the function, f of 6 is equal to 3 times 6 minus 4. It is 18 minus 4. 18 minus 4 is 14. 18 minus 4 is 14. So out comes 14. Alright. So the message that the scammers see is negative 1, 5, 17, and 14. Well, they will suspect that the message you're seeing is an encoded message, because you're supposed to have 4 digits for your ATM card number, and none of them is supposed to be negative. Right? So, remember, they have copied your ATM card and want to get into your account. They did not use a skimming device to also copy your PIN, so they're trying to intercept your messages to find out what possibly could be your PIN number. Alright, what they see is this, but they don't know what the function is. This is a function. The computer program probably changes the function every 1 minute. Right? Whatever the function is, it has the same inverse. It has its own inverse. So 1 minute, the minute that you sent out the message, this was a function on your phone, and when it reaches your relative's phone, it had the inverse function of this. So let us say we want to find out what the inverse function is. Let's find the f inverse x. F inverse x equals. Now, remember what you do is change f of x to y. Y is equal to 3x minus 4. What's the next step? Remember it? You interchange x and y. So you have x is equal to 3y minus 4. Then the next step, you transpose the formula to make y the subject. So your transposition skills will be needed at this point. You have x equals 3y minus 4. You want to get rid of all the other numbers around y and leave y alone. Get rid of the 4 first. If you add 4 to both sides, you notice negative 4 plus 4 is 0. So you have x plus 4 equals 3y. Then get rid of the 3. Divide by 3. Divide by 3. 3 cancels 3. So you have y equals x plus 4y. So, well, x plus 4y. The x plus 4 over 3, I should say. X plus 4 over 3 is y. But switch it around and say y equals x plus 4 over 3 divided by 3. Then you write y as f inverse of x. And you get x plus 4 divided by 3. Now, that's the inverse function. Let's erase this to make some space for further calculation. I want to pass the encoded message to the inverse function to decode it. So, what I have is f inverse of negative 1. If an f inverse x is x plus 4 divided by 3, let's put negative 1 in there. Negative 1 plus 4 divided by 3 is negative 1 plus 4 is 3. 3 divided by 3 is 1. So, out from this comes 1. Let's use the 5 now. F inverse of 5 is going to be 5 plus 4 divided by 3, which is 9 divided by 3, which is 3. So what we have from the 5, we have 3. Then 17. 17. We have f inverse of 17 equal to x plus 4 over 3. 17 plus 4 over 3. 17 plus 4 is 21. 21 divided by 3 is 7. So out comes 7. Then for 14, we find f inverse of 14. X plus 4 divided by 3 becomes 14 plus 4 divided by 3. Kind of running out of space here. What is 14 plus 4? 14 plus 4 is 18 divided by 3. 18 divided by 3 is 6. So out comes 6. Alright. So your relative will see, your family member will see your PIN number. But somebody between you and your relative using some type of device to capture the electromagnetic waves that are coming from your phone will see -1, 5, 17, 14 because it's encoded. So here you have the original message, the encoded message in red, and then the received message, decoded message, which is the same as the original message. So you can use functions and inverse function to encode messages. So someone trying to intercept that message would not be able to determine what it was. And the thing is, the computer program, it can use more elaborate, more complicated formulas than this. And it can change the formula depending on the day, the minute, and the hour, the day, hour, and minute that the message was sent out. So it becomes extremely difficult to figure out exactly what the original message was by just looking at the encoded message. All right, we will continue relation functions and graph in a different video.